We have partial differentiation. Since we are now familiar with the derivative d over dx of a function, where f is a function of single variable x, so now we are going to consider a function of two independent variables. So let's say we have u as a function of x and y. That is, Ru is equal to f of xy, and as an example, I have here u equals xy cubed minus 2x squared y squared. So partial differentiation takes place when one of the variables is considered constant. So here in our example, we have u as function of x and y. If we're going to consider y as constant, then we can get the derivative. That would be the partial derivative. So let's say we have a function z equals x squared y plus xy squared. So z is a function of x and y. Now, if we are going to consider the variable y as constant, so we will have our function z as a function of x alone. And as an illustration, since y is considered constant, so I will replace y by 2. Then by inspection, makikita natin na z is a function of x alone. As a result, so we can compute the derivative of z with respect to x, and the derivative found in this manner is called the partial derivative of z with respect to x. The same manner will be applied in finding the partial derivative of z with respect to y. With respect to y, so meaning x will now be considered constant. So therefore, so same with our first equation, another illustration tayo. So I will replace x by 2 since x is considered constant. So again, we will have z as a function of y alone. Then we can get the partial derivative of z with respect to y. So we have symbols used in the representation of partial derivatives. So I have here the common symbols used for partial differentiation. First is this symbol. So para tayong may letter D sa ordinary derivative natin. So naging curved lang siya. Kaya yan ay partial derivative of f with respect to y. This is partial derivative of f with respect to x. Also, ginagamit din minsan yung symbol na f sub y. So read as partial derivative of f with respect to y. This is with respect to x. Ito yung common symbols used in partial derivatives. So we have example number 1. Number 1, if z equals x squared y plus xy squared, so we are going to find letter A, the partial derivative of z with respect to x, and B, partial derivative of z with respect to y. So again, z is a function of x and y. So for letter A, we have the partial derivative of z with respect to x. So we have given function z equals x squared y plus xy squared. So with respect to x, so meaning we're going to consider y as constant. So pwede mo siya i-rewrite as z equals y x squared plus y squared x kasi nga ang y ay constant muna. So y is constant, same with y squared. So pareha silang constant. Then as an illustration, again, I will replace y by 2. Kaya meron tayong z equals 2x squared plus 2 squared x. Now, by differentiation, so magkakaroon ka ng 2 constant, derivative ng x squared ay 2x, 2 squared, yan ay constant, derivative ng x ay 1. Or simply, we have 4x plus 4. So ito yung principle na i-apply natin sa partial differentiation. So para ka merong ano lang, z as function of x. So, tuloy natin. Then z is now equal to yx squared plus y squared x. Nire-write ko lang siya. Hinarap ko muna yung y kasi ang y ay constant muna. Now, differentiation. So, differentiate natin. So, rewrite yung y constant. Take the derivative of x squared plus y squared. So, differentiate x. So, applying formulas, we have y times 2x plus y squared times 1 for derivative of x. Then, simplifying, we have 2xy plus y squared as a derivative or partial derivative of z with respect to x. Now, for letter B, so we have partial derivative of z with respect to y. Again, z equals x squared y plus xy squared. O, ganun pa rin siya. Z equals x squared y plus xy squared. But we're going to consider x as constant. Kasi we're going to find the partial derivative of z with respect to y. So meaning z and y ang ating variables dito. So yung x muna ay constant. Again, meron tayong illustration dito. So palitan muna natin yung x ng 2. Kaya magiging 2 squared y plus 2y squared. Then differentiating 2, 2 squared times 1, derivative ng y. 2, derivative ng y squared ay 2y. Or we have 4 plus 4y. So going back to our example, z is now equal to x squared y plus xy squared. X is constant. So, rewrite lang natin yung constant. Differentiate natin yung y with respect to y. Plus x, constant yan. So, differentiate y squared with respect to y. Then, we will have x squared. Derivative of y is 1. Derivative of y squared is 2y. Then, we have x squared plus 2xy. Partial derivative of z with respect to y. So, we are going to apply same formulas in ordinary derivative. So, kamukha lang naman siya ng common derivative natin. So, we have example number 2. So, we have given a function f which is equal to x cubed minus 3x y squared. Then, for letter A, we're going to find f sub x when x equals 2 and y equals 2. Letter B, f sub y when x equals negative 1 and y equals 3. So for letter A, we have f sub x of 2 and 2. So meaning, we're going to find the partial derivative of the function f with respect to x when x equals 2 and y equals 2. So we have given the function f equals x cubed minus 3xy squared. Now differentiating, we have derivative of x cubed with respect to x minus, so dito yung 3 at yung y squared ay constant. So rewrite lang yan, 3y squared. Then derivative tayo ng x. So ang derivative ng x cubed ay 3x squared. Again, 3y squared ay constant. Kaya 3y squared, rewrite natin yan. Derivative ng x ay 1. Then we have 3x squared minus 3y squared. Partial derivative of f with respect to x. So since we have the partial derivative of the function with respect to x, so we can now solve for its value when x equals 2 and y equals 2. So we're going to replace x by 2 and y by 2. Then we will have 3 times 2 squared minus 3 times 2 squared. Then we have 3 times 4 minus 3 times 4. Or we have 12 minus 12. Then we have 0. So ito yung partial derivative of f with respect to x when x equals 2 and y equals 2. Now for letter B, we have f sub y when x equals negative 1 and y equals 3. So same with letter A, we have given function x cubed minus 3xy squared. So again, our symbol it represents partial derivative of the function f with respect to y when x equals negative 1 and y equals 3. Now, differentiate natin. So we have the derivative of x cubed with respect to y. Dito naman, ang ating ngayong variable ay y. So, rewrite natin yung constant, 3x. Then differentiate y squared. So, ang derivative ng x cubed ay magiging 0. Kasi ang x natin dito ay constant muna. So, ang derivative ng constant ay 0. Then, minus 3x. Differentiate y squared with respect to y. We have 2y. Or simplifying, we have 0 minus 6xy. Partial derivative of f with respect to y. Now, applying the given values of x and y, then we will have 0 minus 6 times x is negative 1, y is 3. Then we have 0. This will become negative 18. So, negative minus tayo dito. Ay magiging plus. 0 plus 18 tayo ngayon. Then we have positive 18 as the partial derivative of f with respect to y when x equals negative 1 and y equals 3. So another example tayo, number 3. If u equals x squared, y raised to negative 1 minus x raised to negative 1, y squared. So show that x times the partial derivative of u with respect to x plus y times partial derivative of u with respect to y is equal to u. So we have here proving of equation with application of partial derivatives. So dapat yung x, pag multiply sa partial derivative ng u with respect to x, at i-add natin yung y multiplied by the partial derivative of u with respect to y, equal dapat sa u sa ating given equation. Simulan natin. So since u is equal to x squared, y raised to negative 1 minus x raised to negative 1 y squared. So we are going to find first the partial derivatives with respect to x and with respect to y. So magsimula tayo doon sa partial derivative of u with respect to x kasi kailangan mo yan sa equation. So yung y raised to negative 1 saka yung y squared. So pareha siya magiging constant. Kasi nga tayo ay with respect to x. So x lang ang variable natin mo dito. Saka yung u. Now, differentiate natin. So ito ay constant, y raised to negative 1. So differentiate natin ngayon yung x squared with respect to x. Minus, rewrite yung y squared, yun ay constant. Then differentiate x raised to negative 1. Then we have y raised to negative 1. Derivative ng x squared ay 2x minus y squared. Derivative ng x raised to negative 1 ay negative 1 times x raised to negative 2. So, paano ito nakuha? Balik tayo ng basic derivative. Yung power x raised to n. So, ang derivative nun ay n times x raised to n minus 1. So, n, x raised to n minus 1 lang tayo. So, binabay negative 1, x raised to negative 1 minus 1 is negative 2. Tuloy natin. Then we have 2x times y raised to negative 1. So, we have negative and negative. I-plus tayo dito. X raised to negative 2 y squared. Partial derivative of u with respect to x. Next, muna tayo sa partial derivative of u with respect to y. Ito naman, tayo ay variables na u and y. Kaya yung x squared at yung x raised to negative 1, sila ngayon yung magiging constant natin. Then differentiating, constant yung x squared. So derivative of y raised to negative 1 tayo with respect to y. Ito naman x raised to negative 1. Then derivative ng y squared dyan. Dapat ito with respect to y. Ano? Parehas with respect to y. Then we have x squared. Again dito, ginamit na naman dyan yung x raised to n. So, n, x raised to n minus 1. Kaya meron ka negative 1. So, negative na yun. Y raised to negative 1 minus 1, negative 2. Then, minus x raised to negative 1. Derivative ng y squared ay 2y. Then, simplifying, we have negative x squared, y raised to negative 2, minus 2, x raised to negative 1, y. Partial derivative of u with respect to y. So, lipat tayo sa proving. Doon na tayo sa kailangang i-prove na kung tama talaga, kung mag-i-equal. So, meron tayo nakuhang partial derivatives. Nakuha na natin with respect to x and with respect to y. Doon tayo ngayon sa given equation. So, we now have the partial derivatives. Doon tayo sa given equation. Check natin kung mag-i-equal. So, the given equation is x multiplied by the partial derivative with respect to x plus y times partial derivative of u with respect to y equal daw sa u. So, recall natin kanina, nakuha ang partial derivative ng u with respect to x ay 2x y raised to negative 1 plus x raised to negative 2y squared. And our partial derivative of u with respect to y is negative x squared y raised to negative 2 minus 2x raised to negative 1 y. Palitan natin. Sabi dito, x multiplied by the partial derivative with respect to x. Kaya meron tayong x. Ito ngayon yung ating partial derivative of u with respect to x plus y. Ito naman yung ating partial derivative of u with respect to y. So, equal yan sa u. Then, ayusin natin equation. Multiply lang. So, magiging x multiplied by the partial derivative plus y partial derivative equals u. So, ang u ay equal sa given kanina, x squared y raised to negative 1 minus x raised to negative 1 y squared. So, yun ang katumbas ng u. Then, by multiplication, so we have 2x squared y raised to negative 1 plus, multiply dito, magiging x raised to negative 1 na lang siya, y squared, plus y, multiply mo sa ating equation dito. So, magiging negative x squared, multiply mo dyan, negative 1 na lang y, minus 2x raised to negative 1, y times y is y squared, rewrite yung u. So, ito at ito ay similar. Yung dalawa na yan, pwede mo sila i-combine. Kaya 2 plus negative 1, we have positive 1 x squared y raised to negative 1. Ito namang x raised to negative 1 y squared ay similar naman dito sa negative 2 x raised to negative 1 y squared. Kaya meron kang 1 plus negative 2, we have negative 1, negative x raised to negative 1 y squared. So, equal yan sa u x squared y raised to negative 1 minus x raised to negative 1 y squared. So, silang dalawa ay nag-equal. So, ibig sabihin, tama yung given equation. Na-prove natin na sila ay equal. So, ito ay proving na may application tayo ng partial derivatives. So, From example number 1, yun ay z equals x squared y plus xy squared. Our example number 2, the given function is f of xy is equal to x cubed minus 3xy squared. Our example number 3, sa proving natin, given yung u doon as x squared y raised to negative 1 minus x raised to negative 1y squared. So if we are going to examine the 3 examples, so lahat siya na i-define explicitly. So meron ka kagad dyan z, function of x and y. F, function of x and y din. U, function of x and y. So lahat siya nakadefine kagad. No, na a function of x and y tayo. So paano pag ang given ngayon ay hindi kagaya ng 1, 2, and 3 na yan. So for number 4, so our function is x cubed z squared minus 3xy cubed z equals x cubed minus 2y squared. And we are going to find the partial derivative of z with respect to x and the partial derivative of z with respect to y. So dyan, hindi mo pwedeng gawin yung equation mo as z function of x and y. So di mo siya maaayos. So balik kayo ng implicit differentiation. No? Review tayo muna. No? Review. So paano ba ang implicit differentiation? Ang implicit function, ito yung mga function na hindi pwedeng i-define as function of x or function of x and y. So halimbawa, meron tayong given equation. We have x cubed plus 3xy cubed equals x plus 2y squared. So pag chinek mo yan, so hindi mo siya pwedeng ayusin as y function of x lang. So magkahalo ito x and y kagad siya, no? Ang ating equation. And we are asked to find the derivative of y with respect to x. Ito ay review lang ng partial differentiation. Review tayo ng implicit differentiation. So implicit differentiation is similar with the common differentiation. Ang pagkakaiba lang, so it follows dy over dx upon differentiating the variable y. So paano nangyayari? Kung meron kang x squared, ang derivative ng x squared ay 2x. Ngayon, pag meron tayong y squared, ang derivative niya ay 2y, kaya lang may kasama siyang dy over dx or y prime. So, yun ang kaibahan. Pero same tayo ng formula na ginagamit. Sige, tuloy natin dito. Dito, meron kang product ng 3x saka ng y cube. Dito kasi sa ating given, yung y at x ay variable yan. So, pag sila ay naka-product, apply mo ngayon yung derivative ng product na ub. u db plus v du tayo. Differentiate natin. So, ang derivative ng x cube ay 3x squared. Since ito ay naka-product, so we have our first function 3x. Derivative tayo ng y cube plus y cube derivative of 3x. So, equals derivative ng x ay 1 plus ang derivative ng 2y squared ay 4y dy over dx. Doon sa, sa bawat derivative ng y, laging mayroong dy over dx. So, yung sinasabi sa rule ng implicit differentiation. Tuloy natin. We have 3x squared plus 3x times, this will become 3y squared dy over dx plus y cubed, derivative ng 3x ay 3, equals 1, rewrite lang ito, plus 4y dy over dx. Then we will have 3x squared plus, multiply ito, magiging 9xy squared dy over dx plus, ito rin, multiply 3y cubed equals 1 plus 4y dy over dx. Then, ayusin pa natin, removing grouping symbol, we have 3x squared plus 9xy squared dy over dx plus 3y cubed equals 1 plus 4y dy over dx. So, paano gagawin? Itong may dy over dx ay kailangan mong ilipat doon sa kabilang side na equation. So, transpose dapat yan. Kailangan magkasama yung unknown, hinahanap natin. Ito namang 3y cubed at 3x squared, kailangan i-transpose natin. Makakasama nung 1 sa ating right side. Then, magkakaroon tayo ng 9xy squared dy over dx. Lipat ito, minus 4y dy over dx equals 1 minus, lipat yan, 3y cubed minus 3x squared. Then, by factoring, ito ay common nila. So, common yan. Common, pwede mo siya i-factor out. So, ayun, nilabas natin. Kaya dy over dx, may iwan na lang ay 9xy squared minus 4y equals 1 minus 3y cubed minus 3x squared. Then we divide both sides by 9xy squared minus 4y. So, magkakancel ito. So, ito. Then, we can now solve for dy over dx na equals sa 1 minus 3y cubed minus 3x squared all over 9xy squared minus 4y. Ito ngayon yung derivative ng y with respect to x. Ito yung concept ng implicit differentiation. Lipat tayo ngayon sa ating example. So dito, meron tayong x cubed z squared minus 3xy cubed z equals x cubed minus 2y squared. At ang pinapahanap dyan ay partial derivative ng z with respect to x. So, ibig sabihin, kagaya ng implicit, pag nag-differentiate tayo ng z, lagi siyang may kasamang dz over dx. Pagka tayo with respect to x. Pagka naman with respect to y yan, lagi siya may kasamang dz over dy, yung variable na z. Okay, simulan natin. Let's start with partial derivative of z with respect to x. So dito, we're going to consider y as constant. Kasi ang ating variables dyan ay z and x lang muna. So again, x cubed minus z squared. X cubed z squared minus 3xy cubed z equal yan sa x cubed minus 2y squared. So yan ang given sa atin. So itong x cubed at yung z squared, yan ay nakaproduct. Product yan kasi parehas silang variables. So mayroon kasi tayong variable na z and x. Ito ring 3xy cube saka ang z, yan din ay product. Simulan natin. Sa una, so we have x cube. Ang derivative ng z squared ay 2z. Saka yung dz over dx natin. Plus z squared, ang derivative ng x cube ay 3x squared. So ito yung para sa unang product, x cube and z squared. Minus, so we're going to use again grouping symbol. Ang unang function mo dyan ay 3xy cube. Ang derivative ng z ay 1. Saka dz over dx yan. Plus z. Ang derivative naman nito ay 3y cube. So ano nangyari doon? Kasi dyan, meron kang derivative ng 3xy cube. Ito yun. Again, yung 3y cube ay constant. Kasi ang y ay constant dito. Ano? So ang variable mo ay x, saka yung z. So magiging 3y cube tayo times 1. Kasi ang derivative ng x ay 1. Kaya meron ka lang doon 3y cube. So equal yan sa derivative ng x cube ay 3x squared. Itong 2y squared, yan ngayon ay constant. Kaya ang derivative niyan ay 0. Simplify natin. So ito yung magiging 2x cube z dz over dx plus 3x squared z squared. Again, minus. Ito naman ay 3xy cubed dz over dx plus 3y cubed z equals 3x squared. Now, removing this bracket. So, kasama may sign dyan. Pag i-remove yan, kaya magiging negative, negative. So, we have 2x cubed z dz over dx plus 3x squared z squared minus 3x cubed, 3xy cubed minus 3y cubed z equals 3x squared. So, ngayon, dalawa na to, kailangan niyang i-transpose kasi wala silang dz over dx natin. Then, meron ka na lang 2x cubed z dz over dx minus 3xy cubed dz over dx. Nilipat yung dalawa equals 3x squared plus 3y cubed z minus 3x squared z squared. Then ito, saka ito ay common. Yan ating hinahanap. So, pwede mo siyang i-factor out. Lalabas natin yan. So, ayun siya. Lalabas natin. Ang may iwan na lang ay 2x cubed z minus 3x y cubed. Equal ngayon to. Rewrite lang itong tatlo na to. 3x squared plus 3y cubed z minus 3x squared z squared. Then again, we divide both sides by 2x cubed z minus 3xy cubed to solve for the partial derivative of z with respect to x. So, makakancel ito. Then, our partial derivative of z with respect to x is equal to 3x squared plus 3y cubed z minus 3x squared z squared all over 2x cubed z minus 3x y cubed. So, ito yung partial derivative of z with respect to x. Now, for letter B, doon naman tayo sa with respect to y. Dito naman, we're going to consider x as constant. So again, our given equation is x cubed z squared minus 3x y cubed z equals x cubed minus 2y squared. Dito naman, ayan, meron dyang y saka z. So yan ay naka-product. Ayusin natin. Dito, ang x cube ay constant yan. O rewrite mo lang yung x cube na yon kasi yun ay constant. Differentiate mo yung z squared. Kaya meron kang 2z, dz over dy. Minus, doon tayo sa may product. Ito ay product. Ito muna ang ating pinaka-first function, 3xy cube. Ang derivative ng z ay 1, dz over dy tayo. Plus z times 9xy squared. So, paano nangyari dito? Naging ganyan. Ito siya. So, ang derivative ng 3xy cube ay magiging derivative tayo ng, ayun, ang 3x ay constant. Ang variable mo ngayon ay y cube. Kaya magiging 3x yan. Labas yung 3x. Derivative tayo ng y cube. So, meron ka ngayong 3x times 3y squared, derivative ng y cube. So, multiply yan, magiging 9x y squared. So, equal yan sa derivative ng x cube, yan kasi ay constant, kaya 0. Derivative ng 2y squared ay 4y. So, ito ngayon yung ating magiging sagot. Now, simplify natin sa 2x cubed z, partial derivative of z with respect to y, minus 3xy cubed dz over dy plus 9xy squared z equals negative 4y na lang siya. Then removing grouping symbol, so magiging ano yan, ito yon, negative ng 3xy cubed dz over dy, negative of 9xy squared z equals negative 4y. So again, pag inayos natin, transpose lang itong isa, itong 9xy squared z. Ito na naman dalawa ay may common na dz over dy. So, common nila yan. Pwede mo siya i-factor out na naman ulit ayon. So,
nilabas natin yung dz over dy nila. Meron ka na lang 2x cubed z minus 3x y cubed. So, equal yan sa 9x y squared z minus 4y. Then again, divide natin magkabilang side by 2x cubed z minus 3x y cubed. So, para ma-solve natin yung partial derivative of z with respect to y. So, cancel ito. Cancel din itong isa. Then we have our partial derivative of z with respect to y equals 9x y squared z minus 4y all over 2x cubed z minus 3x y cubed. So, ito yung ating partial derivative of z with respect to y. So, ganun siya, no? Hawig siya ng concept ng implicit differentiation. Kaya lang ito, meron ka ng 3 variables na, ano? Meron tayo dito, x, y, z na tayo. Tayo sa last example, number 5. So, meron itong kahalong trigonometric. So, meron tayong function na x cubed cosine of y minus 2z minus 3 equals 2y sine of 4xz. So, again, ito yung ating given function. Pinapahanap lang dito is yung partial derivative ng z with respect to x. So, sa una, again, kapag ito ay with respect to x, ang variable mo ngayon dyan, z and x lang. So, yung y ay constant. So, sa unang part natin, meron tayong x cube. Ang nakamultiply sa kanya ay cosine of y minus 2z. So, ibig sabihin, nakaproduct yan. Kasi variable ito, ito rin ay variable. So, apply mo ngayon yung derivative ng UB. UDB plus VDU. Doon tayo pupunta muna. Ibig sabihin niya ay x cube. Derivative tayo ng cosine of y minus 2z plus cosine y minus 2z derivative of x cube. Then we have x cube. So, ang derivative ng cosine u ay negative sine u du. Kaya negative sine of y minus 2z. Ang derivative nitong pinakayo natin ay 0 para sa y minus 2. Kaya negative 2 lang yon dz over dx. Plus, dumano tayo sa cosine. Cosine y minus 2z. Ang derivative ng x cube ay 3x squared minus 0. Derivative ng 3 equals 2y. O, ano ba ang 2y? Ang 2y ay constant. So, relate lang yan 2y na yan. Ang derivative naman ng sine u ay cosine u. So, meron kang cosine u du. Sine u, cosine u, du. So, paano nangyari sa du? Yung kasing pinaka-u ng cosine mo dito, no, sa may sine na yan, ang u niyan ay 4x times z. Ang variables mo ay x and z. Kaya yung 4x multiply sa z, yan ay product. So, doon ka ngayon sa 4x, derivative ka ng z, plus z, derivative ng 4x. Then, we will have 4x, ang derivative ng z ay 1, dz over dx yan, plus z, ang derivative ng 4x ay 4. Tuloy natin. Now, simplifying, so we will have negative 2 times negative is positive 2 times x cubed. Kaya meron kang 2x cubed sine of y minus 2z dz over dx plus 3x squared. Multiply mo sa cosine. Kaya 3x squared cosine of y minus 2z equals, so ito ay 2y cosine of u or cosine 4xz times, ito ay 4x dz over dx plus 4z. Isin pa ulit natin. We have 2x cubed sine of y minus 2z dz over dx plus 3x squared cosine of y minus 2z. So 4x, ito muna, 4x, multiply mo sa 2y, magiging 8xy cosine of 4xz dz over dx. 4z, multiply mo dito. Kaya meron kang 8yz cosine of 4xz. Ito ay kailangan nating i-transpose. Ito namang isa ay kailangan mo ring i-transpose. Kaya magiging 2x cubed sine of y minus 2z dz over dx minus 8xy cosine of 4xz dz over dx equals 8yz cosine of 4xz minus 3x squared cosine of y minus 2z. Then again, ito ay common nilang dalawa. Pwede mo yung i-factor out. Kaya magiging dz over dx, ilabas natin yon times 2x cubed sine y minus 2z minus 8xy cosine of 4xz equals 8yz cosine 4xz minus 3x squared cosine of y minus 2z. Then we divide both sides by 2x cubed sine y minus 2z minus 8xy cosine 4xz. So yan ay makakancel. Then makukuha ngayon yung partial derivative ng z with respect to x na equal sa 8yz cosine of 4xz minus 3x squared cosine of y minus 2z all over 2x cubed sine of y minus 2z minus 8xy cosine of 4xz. Ito yung partial derivative ng c with respect to x. So balian ng concept at principle ng partial differentiation. So nagbigay tayo dyan ng function na naka-express kagad siya as function of x and y. Meron din tayo dyang ina-applyan pa ng implicit differentiation para ma-solve mo yung unknown. So yan ang concept ng partial differentiation.